Okay, SHM, Simple Harmonic Motion question. June 2010, Edx M3, question 7. There's the question. Obviously you need to pause the video and have a careful read of it, and then we'll get started on the first part. So, it's a light elastic string, it's hanging vertically, and the first part involves finding the equilibrium position. O is where it's hanging at equilibrium. So I've drawn the diagrams. At equilibrium, T equals 2mg. So we've got 2mg equals, that'll be lambda x over L, so 6mg, let's call the extension E, over natural length 3a. So, carrying on down here, we get E from that with a bit of tidying up. E equals A. So AO equals a total distance of 4A. Now, the particle is raised to a point C vertically below A, where AC is greater than 3A, so the string is still stretched. I've drawn another diagram here for this part of the question. So it's raised to the point C, AC is still bigger than 3A, so the string is still taut. And it's released from rest. Now, that means that will be, it was at rest there, so C will be at the amplitude. Okay. What I've drawn here is a general point in the following motion, where we've got the two forces 2mg and t, and the particle is at a distance x from O. So the equation of motion for that is 2mg going in the direction of x double dot, as shown on the diagram, which would be positive in the direction of x increasing, so downwards. 2mg minus t equals 2m x double dot. Now, the tension at that point is lambda, which is 6mg, over L, which is 3a, times the extension at that point, which is, because we're measuring x from O, A, because that was the extension at the equilibrium position, plus x. So you might like to pause the video and just check that you understand what I've done there. So that's the tension of the string. A plus x is the total extension at that point, as shown in the diagram over here. And completing that, it's equal to 2mx double dot. So now, if you've done this right in this sort of question, the 2mg, the weight, will cancel out with the lambda over L times the equilibrium extension, and you'll get the, as we have here, we'll get the SHM equation. So what we end up with is minus 6mg over 3a x equals 2m x double dot, and that tidies up to minus g over a x. So omega squared is g over a. Just fit that in, bit short room here. Omega squared is g over a. T equals 2 pi over omega, which is 2 pi square root of a over g. Correct. That's what they want. Okay, so that's parts A and B done. Let's go on to the next bit. Now they're telling us that OC is a quarter A. Now C was where it was raised to and released from rest. So that must be at the amplitude. In other words, the amplitude is the distance OC. So amplitude equals A over 4. And the other thing that we know from the previous screen is that omega is root g over A. So now it's easy, should be easy if you know your SHM equations. Vmax, the greatest speed, is A omega, and it occurs at the center of the SHM. So Vmax, in this case, is A over 4 times root G over A. Or we can write that as a quarter root GA. That's part C. Now the point D is vertically above O, and OD equals an eighth of A. Let's just jot that down for a minute. So D is here, there's O, that's A over 8. That's still part of the SHM, remember, because the amplitude was A over 4, so A over 8 is still well within that. What we're interested now in is what the speed here is, because what we have to find is the greatest height of P above O in the subsequent motion. Right, so if we can find the speed at this point, it'll then travel freely under gravity, and we can find how far it goes up. So the equation for the velocity is that in SHM, just quoting it, and that becomes putting the values in here. So we get V squared equals 3GA over 64. That's just equals this, right? V squared that. And the last part then is simply the last stage of this is simply to find how high that goes. So let's use V squared equals U squared plus 2AS. I'll just write that down to show what I'm doing. And we get naught equals 3GA over 64 minus 2GH, giving H equals, again, you check this, sorry my pen hasn't worked very well there, that gives H equals 3A over 128. Now have we answered the question? We want the greatest height of P above O, so the total height above O, because it's been travelling since it left the point D here, which was already a height of A over 8 above O. So the height above O, just got room to fit this in, if my pen works properly. Height above O, A over 8 plus 3A or 128, which is 19A over 128. Struggling with my pen for some reason. 19A, that's supposed to say, over 128. Just about managed it. Right, so the marks for that then. Let's go back to the first part. Okay, what happens is we've got a B1 mark for seeing that the tension is 2 mg and an M1A1 for the method and getting the distance AO is 4A. Then for the proving SHM, we've got basically 4 marks, or no, 5 marks for that part. Yep. And it goes as follows: an M1 mark for constructing the Newton's second law equation there, and a B1 mark for getting this version of it right after putting the tension in. An A1 mark for getting the expression for x double dot, and an A1 mark for getting the tension. Is that right? And there's one more method mark, I beg your pardon. There was a method mark for this stage as well. Yeah, that's the 5, isn't it? That's that part. And then skip that. We don't need that screen. For the last bits then, we've got a method and 2 accuracy marks for, well, for stating that for figuring out that the amplitude is A/4, there's a method mark, and there's 2 accuracy marks, one for stating that, and one for correctly calculating the maximum speed. For finding the velocity that it takes off with at d, there's a method mark for quoting the formula there, a method mark for finding the v squared correctly at this point, an accuracy mark for finding the h by using v squared equals u squared plus 2as, and an accuracy mark for the final value. Right, that's it. Okay, rather a long, involved, well, not particularly difficult question, but quite a long question, but quite a few marks for it. So I hope that was useful. Here's a bit more information about the Further Maths Support Program, and thank you for listening.